Hello everybody, this is the fourth video clip of our chapter 3 for the course Calculus for Business 2. Okay, what we have learned before is that if we are given z as a function of x and y, then a derivative of z with respect to x can be interpreted as the rate of change of the z value with respect to the x value. Okay, that change alone, not the y. So if your dz by dx is positive, then it means that your z will increasing when your x increases, okay, but your y is fixed. On the other hand, if your dz by dx is negative, then it means that your z is going down, okay, decreasing whenever your x is increases and your y is fixed, okay. And on the same token, if you talk about dz by dy, if your dz by dy is positive, then it means that your z will be increasing as your y increases and your x is fixed. And if your dz by dy is negative, then it means that your z is decreasing whenever your y is increases and your x is fixed. Okay, so this one is the reflection or in the interpretation of the rate of change of z with respect to with respect to y. Okay, so today we are going to use this kind of interpretation, okay, to go over another application of your partial derivative. Okay, so it says that sometimes two products may be related such that the change in the price of one of them affect the demand of the others, right? So if such a relationship exists between a product A and a product B, then the demand for each product is dependent on the prices of both. So for example, if you let your Q sub A be the quantity demanded for the product A, and the Q sub B is a quantity demanded for product B, and of course the P sub A is the price per unit of the product A, and P sub B is a price per unit of the product B, then usually your Q sub A is the function of both price P sub A and P sub B, and your Q sub B is going to depends on both P sub A and P sub B, right? So here is the demand, okay, in terms of PA, PB, and the demand depends on the two prices PA, PB. So it means that if you find a derivative of the demand of the product A with respect to the price A, is a marginal demand of A with respect to PA. So what does this mean? Let's try to interpret it in terms of economics, okay, or in terms of business. The demand is the quantity that people need to buy, right, at this particular price, okay. However, this one is the rate of change of the demand that people want as your price change. So usually when we say the price change, then it means that if the price is going up, right? If the price of the product is going up, so I mean basically, will people buy a product A if the price is going up? So of course, I mean people don't want to buy A, right? So it means that your DQA, the rate of change of the demand when your price is going up, must be, okay, negative. This one is a must, okay, always like that, right? Because I mean if A is more expensive, why bother buy it, right? Okay, so the demand will decreasing immediately. On the same token, if you're talking about the demand of the product B with respect to the price of the product B, so it means that now we are going to measure the change of the demand as your price B is going up, right? So immediately, if your B is getting expensive, okay, getting more expensive, the demand for the product B will be decreasing immediately. Okay, so this one is a must as well. Okay, so if so it means that if you find DQA with respect to the price A and you got something else rather than negative, then it means that you may have the wrong calculation, or you may got the wrong demand function. Okay, this one as well. Okay, the rate of change of the demand with respect to the price B, it must be negative. However, if the price B, so this one, if the price B is going up, what happened to the demand of the A? So the demand of the A, the rate of change of the demand of the A with respect to the price B, maybe it is positive or negative. So if it is negative, positive, then it means that people need A more, right? And this one, people don't need A, okay, right? Okay, people may not need A. And this one as well, if your price of the product A is going up, your demand for the product B can be either positive, which means that people will need B more, or it can be negative, so it means that people don't need B as well. Okay, so it can be either this way or this way. All right, for for the derivative of the different quantity and the different price. All right, so let us interpret what will happen. Okay, so as I told you, this is the typical thing that is going to be like this all the time, so it's a must. Okay, however, for this one, we still don't know what will happen. Okay, so what if it's saying that this is must be n. Okay, if the price B is going up, the quantity for the product A is going up. So what does this mean? And on the same token, the price A is going up, the demand for B is going up as well, because they are positive, right? So what does this mean? This means that your B is more expensive. So if your B is expensive, people don't buy B, but they buy A instead. On the other hand, if your A is more expensive, people of course don't buy A, but they buy B more instead. So it means that the A and the B can be, replaced. Okay, replaceable. So if they are replaceable, then we can call it competitive product. For example, your A can be, a chicken, and this one can be a pork, right? So if your pork getting more expensive, we can buy chicken, right? It's also protein, right? Or if the chicken is more expensive, we rather buy pork, is it? Don't bother buy chicken, all right? Okay. On the other hand, if both of them again, okay, it must be both of them, and if the price of B going up, but the demand of A going down, okay, it's negative, or the price of A going up, and the price of A going up and demand of B going down. What does this mean? If the B getting more expensive, of course people don't buy B, right? And at the same time, people also don't buy A. Or if the A is more expensive, people don't buy A, and at the same time, people don't buy B as well. So it means that if you buy A, you need to buy B together, or if you buy B, you need to buy A together. So it means that these two products are complementary. Usually the old kind of example for the complementary product, it is the film and the camera, right? People, if people buy camera and don't buy film, then the camera cannot be used, right? Or people buy film but not the camera, then you cannot take a photo as well. In like 5 years ago, this kind of example may be too obsolete, okay? But nowadays they just come back again, because you guys know that all the all the teenagers now, they turn back to use a camera and a film again. Okay, so this can be another good example for the complementary product. All right, So for example, let's look at this. Of course, if it is something else, for example, if you got the QA and the PB is positive, and the QA with respect to the B with respect to the price A, it is negative, okay, or the other way around, if they are in the, in a different direction like this, okay, we'll say that your A and your B has no relation, okay, has no relation. It is not competitive, it's not complementary, okay. So either competitive or complementary, you need to check both, okay. It has to be satisfied the same direction both. Are we good? So for example, let's look at this product, okay, and let me just rewrite this one a little bit, okay. So this is just a rewrite, okay. We still haven't do any kind of derivative. So this one, the third root is 1/3, and this one, PA, it is 1 over a square root, so it is negative 1/2. This one as well, 75 PA and the PB raised to the power negative 2/3, so that will be easier to find a derivative. So first you need to find a 4 marginal demand function, so you need to find all of them. So let's look at the first one. If you find the derivative of QA with respect to the price A, what do you expect? You are going to have, this 50 PB raised to the power 1/3 is nothing but your constant, right? So a derivative go directly to your PA raised to the power negative 1/2, which is negative 1/2 PA raised to the power negative 3/2. And you can see that here they're positive, the price must be positive, the price must be positive. So this one indicate a negative. So this one is the one that you expected, that it must be negative, okay. So it is like what you expected, okay. How about your DQA with respect to the price B, okay. So now it means that the derivative will go directly to your PB raised to the power 1/3, okay. So the thing like 50 PA raised to the power negative 1/2 is right there, and this one becomes what? Becomes 1/3 PB raised to the power negative 2/3, okay. And I mean 50 is positive, the price, both of them are positive, this one is also positive. So each and every terms are positive, then it means that your derivative of the QA with respect to PB, it is positive. But you still cannot conclude anything, okay, until you look at your QB as well. Are we good? You need to look at your QB as well. So let us have another page here, and your QB, a derivative with respect to their own price, what do you expect? So this one, your price going up, this one must be going down, right? So let's see, this is a constant, derivative go directly to your PB raised to the power negative 2/3. So you have your PB and then another 5/3, is it? Right? And again, they are positive, price are positive, so this one alone indicate negative, so it is negative as we expected, right? How about your derivative with respect to another price PA? So here is PA, so your 75 PB raised to the power negative 2/3 has nothing to do, but this one, a derivative is 1. So again, if you take a look, here is positive, the price is positive, this one is also positive, so here is positive. What does this mean? It means that you have the QA with respect to the price B is positive, together with the QB with respect to the price A also positive, okay. So let me interpret it again. This one, the B is more expensive, people buy A, this one, the A is more expensive, people buy B instead. So it means that your A and your B are replaceable or competitive. Okay, they are competitive. Are we all right? So I'll let you take a look again. Okay, so find the so we got 4 marginal demand functions, but only 2 of them, which is the dqa with respect to the price B and dqb with respect to the price A, that can determine either it is competitive, complementary, or neither. Okay, so this is the typing version. You can take a look at it if you like. All right, so next we are going to do the same thing with this example. Let me just rewrite this one to be a PA raised upon negative 1 and your PB raised upon negative 2. Okay, so this one, they just ask you directly to classify whether they are competitive or complementary or neither. So it means that immediately you don't need to find all 4 marginal marginal demand, right? So you just directly find demand of the rate of change of demand of A with respect to another price. Okay, so this one, because it is the exponential, so it becomes the same O exponential, right? And then it is a derivative of the inside, which is let me just write down on the other page here. So it is a dqa with respect to the price B, which is the same O exponential, and then a derivative of the one inside with respect to PB, which is negative PA over PB, is it? Okay, or you may write down as what? Negative PA multiplied by PB raised upon negative 1. So your negative PA is nothing but a constant in this context. So you are going to move it out. Okay, then E raised upon negative PA over PB. And you find a derivative of this one, which is negative 1, PB raised upon negative 2. Okay, so here they are all positive, right? Exponential and the price. This one also, the price is positive, but here you got 2 negative. So it indicates that this one will be strictly positive. Is it? How about the other one, your derivative of QB? So let me just write here with respect to another price A. It means that your 16 and your PB raised upon negative 2. Okay, this one, they are constant. Only thing that you need to find a derivative is PA raised upon negative 1, which will give you negative 1 PA raised upon negative 2. So here they are positive, the price positive, so negative indicate here, so it means that this one is negative. So what does this mean? One of them, okay, is negative, the others is positive, so they are not in the same direction. Okay, so it means that this one, it is neither competitive nor complementary. So your A and your B are neither, or they has no relation at all. Okay. So let's read the second problem. So here's the first problem. Let's do the second problem. It says that if the unit price of A and B are, so it means that the PA it is 1,000 and the PB it is 2,000 per unit. Okay, estimate the change in the demand for A when the price B is decreased by 40 and the price A held constant. Okay, so let's read it again. What kind of change that you need? You need the change in demand of A. So it means that you need the dqa. Okay, so the change in demand of A can be represented by dqa. But this one, it says that when the price B decrease, so when the price B change, right, the price B change, and the price A is constant. The price A is constant. So it means that now the change that you need, okay, it is the one with respect to the PB. Okay, so here will be the term that it will involve. Okay, however, we really need to find this one. Actually, what they ask you to do is that you need a QA, okay, when your price A fixed to be 1000, but your price B from this 2000 decreased by 40, and the demand of the original price to 1000 and 2000. Okay, so you need to find this difference. Okay, and actually what you need to find here, you used to do it before, however you do it in a special case. Okay, so let us go back on what we have like on the previous video clip. You know that f sub x at the particular point xy can be found by using a limit as h goes to 0 of f of x plus h y minus f of xy over h. So what we are going to do is that we are going to get rid of the limit and then change this one into the approximation sign instead. So here, as you do the cross multiply, you are going to have your f of x plus h y minus f of xy can be approximated, calculate from h multiplied by f sub x at this point x and y. So here the only change is in terms of x, and that change, okay, h will reflect on this right hand side here, multiply with your derivative with respect to x. Okay, however, I mean, if you look at another angle, if you find your derivative with respect to y, okay, you are going to approximate it by, okay, this one can be approximated by f of x y plus h minus f of xy over the same h, or it means that if you need to find this difference, okay, minus f of xy, it can be approximated by h and then f sub y at this particular point xy. All right, and what we need is actually the change in y. You see, so you need this formula, right? But instead of using f, we now using qa. Okay, we now using qa, and then instead of x and y, you use pa and pb. All right, so it means that, let me just write down again the qa at 1000 and the 2000 and negative 40. Okay, it is negative because you're talking about decreasing, and comparing with the demand at 1000 and 2000, it can be approximated by your h, okay, which is negative 40. So your h can be either negative or positive, all right, depends on whether you say increasing or decreasing, and the derivative of the demand of the product A with respect to the price B. Okay, and at the particular point 1000 and 2000. Okay, so let us just copy this one because we did it before over here. Okay, so it is about PA. Let me just PA e raised to power negative PA over PB, and then divided by PB square. Okay, so I just copy the whole thing here, but then right now you need a particular PA becomes 1000 and PB becomes 2000. So what you end up with, it is a negative 40, and the PA e raised to power negative PA and PB over the PB square. So it means that you got 2000 twice. Okay, so here your 1000 can be cancelled, your 4 can be cancelled, one of the 0 can be cancelled. So what you end up with, it is e raised to the power negative 1/2 with a negative sign here, don't forget, over 100. Okay, so this one is the approximation of the change, and this one should be units, right? So it means that if the price of B is decreasing from $2,000 by this 40,000, but the price of A still stand as $1,000, then the demand of your product A is decreasing. Okay, this negative indicate the decreasing word by e raised to the power 1/2 over 100 units. Okay, so usually, I mean, this one will indicate the decreasing, and then the by how many units, you just use this number without the negative signs. Okay, all right. So what we need you to figure it out by yourself is that if we change, we want to determine the change in the demand of B. If the price of A decreased by $40, same thing, from $100, okay, and the price of B still 2,000, the same. Okay, what will be the change? Okay, what will be the change in the demand of B? All right. So we are going to stop this video clip right here, and then let you guys digest what we have done here with the interpretation. The very important thing is the interpretation. All right, and then we'll see you on the next video clip. Bye bye.